Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, my dear students. I am Mr. Tamer, your teacher of chemistry. I hope you are happy and I hope you are okay. Our topic today is around forms of changes in heat content. Forms of changes in heat content. I have two forms of changes: chemical and physical. Physical changes and chemical changes. Physical changes which can be returned to its natural form another time, and chemical change cannot be returned to its natural or normal change or normal form. Physical changes like standard heat of solution and standard heat of dilution. Chemical changes like heat of combustion and heat of formation. We have studied standard heat of solution and standard heat of dilution and standard heat of combustion. Now we will study with each other's standard heat of formation. What is meant by standard heat of formation or heat of formation generally? Heat of formation, the heat change accompanying the formation of the compound from its elements. I want to form a compound from its elements, like this. H2O2 gives H2O. H2O is formed. To form H2O from its elements, H, it contains H and O. So I will form H2O from its elements, from H and O. H2 and O2 gives H2O. It is called heat of formation. It is here released heat, and it may be absorbed heat. So, if I wanted to define standard heat of formation, I will say delta H naught F, this symbol, the quantity of heat released or absorbed when 1 mole of a compound is formed from its elements, where these elements are in standard state. Standard state, temperature 25 and pressure 1 atmosphere. And here I said 1 mole of a compound. I formed 1 mole, like the last equation, 1 mole of water vapor to form it from its elements H and O, H2 and O2 forms H2O from its elements. It is called standard heat of formation. Standard heat of formation, and its symbol is delta H naught F. What is meant by, it is a question, may come in the exam. What is meant by heat of formation of water equals minus 241.8 kilojoule per mole? I will mention the definition, but I will mention the definition released only, not released or absorbed. Here is released because the sign is negative. So I will say the released heat when 1 mole of water is formed from its elements, hydrogen and oxygen, equals 241.8 kilojoule. 1 mole. I will say released heat and 1 mole of water from its elements, hydrogen and oxygen, equals 241.8 kilojoule. Per mole, I said 1 mole, so I will not mention per mole here. Does the following equation represent the standard heat of formation? This question for intelligent students. I want you to understand the definition. I want have if you understood the definition or not. H2 minus H2 plus H2 half H2 plus half I2 gives 1 mole of HI, and delta H here is positive 25.9 kilojoule per mole. This is standard heat of formation or not? I want you to think with me. It is absorbed, yes, positive, delta H positive or negative, it is equal in heat of formation, positive or negative. But it must be negative in heat of combustion. In the last lesson, we have studied heat of combustion. It must be negative, released. But in heat of formation, maybe delta H positive or negative. It doesn't matter. Half H2 plus half I2 gives 1 mole of HI. 1 mole of HI from its elements, H and I, yes. And delta H positive or negative, it doesn't matter. So it is yes. It is very good, excellent. This question, this equation represents standard heat of formation or not? CO, half O2, CO2, 1 mole of CO2, 1 mole, and delta H, it doesn't matter, minus or negative, release or absorb it, but 1 mole. You may say it is standard heat of definition. No, it is not standard heat of definition, standard heat of formation, but it is not standard heat of formation. Why? Because it is not from its elements, C and O, CO here, not C. If it was C only and O only, will form CO2 from its elements, C and O. But it is not the element of CO2, not the element of CO2. It should be C and O2 only. This question, CO2 gives CO2, delta H doesn't matter, negative or positive, and here 1 mole of the formed compound, and delta H negative, and from its elements, CO2 is formed from its elements, yes. So it will be yes, standard heat of definition. These are elements. What is the heat of formation of these elements? These elements, in their standard conditions, are formed in nature as they are. So they don't need any heat of formation to be formed, because they are found in the nature as they are. Carbon and iron, copper, they are found in the nature as they are, not need heat of formation. What is the heat of formation of these elements? It will be zero. Zero in standard state. Standard state of carbon is graphite. Iron, salt. Standard state of iodine in solid state here. And mercury in liquid state. And nitrogen in gas state, and so on. Chlorine in gas state, and so on. So the heat of formation of these elements is zero in standard conditions. Very good. We will need this information in solving problems. Heat of formation equals heat content. Heat content of any matter equals heat of formation, because heat content is the sum of energies in the compound. So delta H equals H products minus H reactants. Heat content of products minus heat content of reactants. Final minus the initial. Final minus initial. Products minus reactants. Heat content, H is the sample of heat content. Delta H naught formation equal delta H the change in heat content equals delta H formation of products minus delta H formation of reactants, because heat of formation equals heat content. This is my rule. I will depend on it in solving my problems. Example. This is an example. If the heat of formation of methane equals and carbon dioxide equals water vapor equals, calculate the change in heat content of the reaction, delta H. He wants delta H as in the following equation. This equation of combustion of methane, CH4 plus O2 gives CO2 plus water vapor. I want to calculate delta H. Delta H equals what? Delta H of the reaction equals the sum of heat content or heat of formation of products minus the sum of heat of formation of reactants. The sum of heat contents of the products minus the sum of heat contents of the reactants all gives me delta H. I will write the equation, the first step for solving the problem, write the equation and determine reactants and products. Reactants on the left side, products on the right side. We will write products firstly. Products delta H equals delta H of products, formation of products, minus delta H formation of reactants. So I will write products firstly here, products, and reactants here minus reactants here. I have 3 values only. These values on the givens. In the givens, I have the value of methane and the value of carbon dioxide and the value of water. But I haven't the value of oxygen. Why? Who can answer? Because the heat content of any element in its standard state equals 0. Very good. Because it is present in the nature as it is, as oxygen in the gas state. So its heat content or heat of formation equals 0. So now I have the 4 values. I can compensate like here with focusing on the signs and number of moles. You should put number of moles and the sign here on the givens. So I will have minus 802.5 kilojoule per mole. What is the relation between heat of formation and the stability of the compound? There is a relation between heat of formation and the stability of the compound. I can call a compound stable or unstable by calculating heat of formation. This is 3 notes. Very stable compounds have large negative values of heat of formation. Large negative values means these compounds will release more heat to be formed. So they will be very stable in the heat, very stable, thermally stable, because they will release more heat. Negative, large negative means more heat will be released from the compound. So it will be more stable in the heat, more stable in the nature. Compounds not stable at all have large positive values. They will absorb all the heat around them to be formed. So they don't want any heat. So they are not stable at all. If they are in the room temperature, they will be unstable. They will be decomposed. Unstable compounds have small negative or positive values. I have three nodes. Very stable, large negative values. Not stable at all, large positive values. And intermediate unstable compounds have small negative or small positive values. Intermediate. This scale will give you the summary of this relation. Positive, negative, positive, zero, negative. When I walk from the right to the left, from positive to the negative, what will happen to the stability? What will happen? Very stable stability will increase with increasing the negative value. Very good. Stability will increase here. This is the summary of this relation. Question may come in the exam. Arrange the following compounds in descending order according to their stability. Heat of formation between brackets, kilojoule per mole, like this, C2H2 positive, Hi and HgC2N2O2. This is a compound, but it is not present in the nature. Why? Because if I want unstable compound at all, I will choose the more positive value. So if I want to arrange these compounds, arrangement from the least one, the most unstable one. The most unstable will have the higher positive value. Very good. This 270 more than 226. So I will choose this. Then I will choose this C2H2 positive 226. Then I will choose this, not this, but it is Hi, then Hi, then it is the more stable compound CO2 because it has negative sign. Thank you for watching.